and welcome to this step-by-step guide on building a VPN tunnel between a Cisco router and a checkpoint firewall using IKEv version 2. In this video, we will walk through the entire configuration process, covering setting up IKEv version 2 phase 1 and phase 2 parameters, defining encryption and authentication settings, configuring access control rules and VPN domains, verifying tunnel connectivity and troubleshooting common issues. So whether you are securing remote office connections or integrating multi-vendor networks, this guide will help you set up a reliable site-to-site VPN with strong encryption and authentication. So let's get started. So here we have this topology as in our previous video. This network here, this LAN should be able to reach this LAN and vice versa. Here we have our checkpoint gateway and here we have our Cisco router. So why do we need to, or why do we want to use the IKEv version 2? So efficiency, fewer message exchange than IKEv version 1, resulting in faster VPN setup, and built-in support for NAT traversal without additional configurations, better security, supports modern cryptographic algorithms, and perfect forward secrecy. So here I have created this image that shows 8 steps to create our tunnel in a Cisco router. So the first step is define the IKEv version 2 keyring. Second is define IKEv version 2 proposal. Define IKEv version 2 policies, crypto, access list, define transform set, profiles, crypto maps, and then activate on the interfaces. So let's take this step by step. So here I have my router. So let's log in here. And let's start by the first step. So the first step is define the keyring. So let's define our keyring. So in Cisco, an IKEv version 2 keyring is used to define the authentication credentials, like the pre-shared keys, for specific VPN peers. It maps a peer's identity, such as IP address or host name, to the corresponding pre-shared key. This is essential for IKEv version 2 authentication during VPN setup. So let's define our peer first, and let's add its IP address like this, and let's here we define the pre-shared key, my PSK123, and we exit and exit. So next we define our IKEv version 2 proposal with this command. So an IKEv version 2 proposal in Cisco configurations defines the cryptographic algorithms and parameters used during the IKEv phase 1 negotiation. It specifies how the VPN peers will secure the initial communication channel. So let's press enter here, and it says to us what should we configure here. So first let's take the encryption as ACE256, the integrity is SHA-256, and Diffie-Hellman group 14. And we exit this step. Next step is define our IKEv version 2 policy. Like this. In a Cisco configurations, an IKEv version 2 policy determines the rules and order of proposals for IKEv phase 1 negotiations. It references one or more IKEv version 2 proposals and define how peers agree on security settings for establishing a secure channel. So let's press enter there, and we create our proposal like this. So proposal, and give it a name, and exit So next step is define our access list. So let's define this access list. So a crypto access list is used in Cisco configurations to define the interesting traffic. So the traffic that should be encrypted and secured using the IPsec. This access list specifies the source and destination networks or hosts that will be protected by the VPN tunnel. So let's press enter here once and define our access list. Here we can see 1066, which is this network here, should reach this network here. As we can see, press enter and exit. Next step, we define our transform set, something like that. In Cisco, a transform set defines the encryption and integrity methods used to secure data during the IPsec phase 2 of a VPN. It specifies the exact cryptographic protocols that both VPN peers must agree upon to establish and secure the IPsec tunnel. So let's press enter here and exit. The next step, define our profile or IKev2 profile. Like this. The IKev2 profile in Cisco configurations is used to define the specific parameters for identifying and authenticating VPN peers during the IKev2 negotiation. It links together settings like pre-shared keys, authentication methods, and match criteria for a secure VPN connection. The profile acts as a centralized configuration that router references for managing IKev2 sessions. So let's press enter here once and add. So here we match our peer. And the next command, we use a pre-shared key for local authentication, and we use a pre-share for the remote authentication. And we reference our keyring that we have created previously. And we take exit here. Next step is define our crypto maps. So with this command, so our crypto map is called checkpoint crypto map. So a crypto map in Cisco configurations is used to apply IPsec policies to an interface, enabling secure communication for specific traffic. It ties together all the elements necessary for VPN operation, such as peer IP addresses, transform sets, and access lists that define the traffic to encrypt. So let's define our peer again here, like that. Let's activate PFS with group with Diffie-Hellman group 14. Let's choose our lifetime, which is default by 3600 seconds. Let's reference our transform set. Let's reference our profile here. And then we match our access list. And we exit. The next and the last step on the Cisco router, we need to activate or apply our crypto map on the interface. So our external interface in this case is this one, so Giga00. So let's go to Giga00 and apply that like that. So as we can see here, ISACamp is on. So now we are done configuring our router. Let's save our configuration here, and now we can go to our checkpoint gateway. Let's see if VPN, okay, it's enabled. So let's directly create our community here. Let's call this Cisco IKEv2 test, for example. Pick legacy here, add the gateway, this one, 32, and here we add our Cisco router. Let's define our VPN domain. So from the gateway side is this one. As we can see here, this network is our VPN domain. And from the Cisco side, define the 1066, which is this network here, or this interface. So, encryption now. So here we are using only IKE version 2. We can choose this option, prefer IKE version 2, support IKE version 1. But for the sake of this video, let's stick with this option here. So as we configured in our Cisco router, encryption algorithm is ACE256, data integrity is SHA-256, and Diffie-Hellman group 14. Same here, ACE256, SHA-256, and perfect forward secrecy is group 14. Let's define our shared secret here. And the secret was my PSK 123, so my PSK 123, something like that. Okay, and okay. So let's install our policy here, and then we can directly test the connection. So to test, we need to ping. If we are going to test from the router, we need to use this interface here to ping this interface, and vice versa if we ping from the gateway. So let's pretend that these are not here, and we need to ping from the gateway here. You cannot use just only ping. You need to specify this interface. I will show you how to do that. The same is correct from the router. So let's see if the installation process is progressing. Okay, now the installation process is done. So let's go to our router. So let's take end here and ping 172.25.10.1, and we need to specify the source, and we add gigabit 0/1. So source is this interface here, 0/1. And let's test that, and we can see success rate here. So try again, it will just go fine. So let's ping from our gateway. So admin here. Okay, we need to go to the expert mode here to do that. So ping and big I, and we need to define our interface, the ETH one. So as we can see here, this interface, and we are pinging 10.661, and as we can see here, it is okay. So let's check our logs here. VPN, let's take one more, see. Okay, we can see that we are good to go. So it's decrypting and encrypting and decrypting. So let's generate more, maybe more traffic. More traffic here, more traffic there. Okay, let's try to ping from our from these devices, and then we can see more logs. So this one, let's open this one. Okay, ping 10.6.6.1. Okay, it's pinging 10 ping 2, and it's fine. So let's try from the other side. Ping 2 5 1. Okay, let's try 2. Okay, so let's reload this, and now we can see all this encrypting, decrypting, encrypting, key installation. So let's check in our router. So show crypto IPsec SA to see that we are having packets, encrypted packets, decrypted packets. Here we can see that our configuration is working well. At the same time, we can do the same on checkpoint. Here we can use the command VPN tunnel. Let's exit from this VPN tunnel. Let's try to see. Here we can see that we have IKEv2, as we can see here. But I thought about another command. So VPN tunnel, I think tlist or something. Tlist. Okay, so here we can see more info. One IPsec tunnel. We can see tunnel source. Our tunnel source is this one. The peer tunnel source. This TS means tunnel source. Is 10.6.6. Created this time, so it is 1 hour. Only 1 hour. What we can see here, we can see what methods are we using. PFS ACE256, SHA256. So much information. Let's try to grab this. Okay, so for example, we can take list IKE, something like that. We can see the same, and list IPsec. So as you can see, there are many different commands that you can use to show that your tunnel is up and running. So as we did there, we can see that we have site-to-site tunnels are up, IPsec 1. This is very interesting to have in this page. So this video is done here. So thank you for watching, and see you in the next video.